Excellent, excellent. Right, okay, Fernanda, good afternoon. Croeso, welcome everybody to our afternoon session where we'll be looking at how we shape research to unlock the ocean's potential. So we've got an excellent panel for you this afternoon. Unfortunately, one of our speakers had to drop out, and that was Professor Tim Stallard from Supergen, but it just means everybody else now has a couple more minutes potentially to be able to present to you, so it's not bad news by any means at all. So, research has a critical role to play in the need to sustainably source marine energy. This session will provide updates from Welsh and UK-wide research and identify how to maximise collaboration and impact your post-EU funding. I'm Steve Hall. I'm the Chief Executive at the Pembrokeshire Coastal Forum, which is the parent body of Marine Energy Wales, and I'll be your chair for this session in Tim's behalf, as he wasn't able to be there. Just wanted to highlight quickly before we move on, just the news that the Marine Energy Test Area received its marine license this week and is, of course, the perfect bed for research and testing of your innovative solutions and research methods. So the parameters of the license are designed to ensure a broad range of test capabilities in an accessible and sheltered environment, as well as a real sea open water areas, which are still relatively accessible from the sort of Pembroke Dock greater area. So we'll be working with projects from some of our panelists to explore the options to support with the Offshore Research Catapults MEIS project and also with the Interreg project Selkie. So looking forward to hearing from the panelists how Wales can continue to engage with academic and research initiatives across the UK and Europe. So first up is going to be Jennifer Fox from the Offshore Renewable Joint Industries Programme. We'll then move on to Lewis Levay. He's from the Centre of Applied Marine Sciences at Bangor University, the CCAMS 2 project. We'll then move on to Professor Ian Masters from the University of Swansea, talking about their work on Selkie, the cross-border project bringing together leading researchers and businesses to improve the performance of marine energy devices. Then Catherine Tate from Aquaterra, then Robert Spice from ITP Energized, and then we should have about 20 minutes available for a Q&A session before we move over to the closing comments at the end of the conference. So you should be able to see each of the panelists as they present. Do feel free to submit your questions via the chat button on the right-hand side of your screen, and Jay and I will endeavour to collate the questions and pass them to the panelists so they're able to answer as many questions as we possibly can. Please feel free to submit the questions as we go through the session and as they come into your mind. The chat option is also available for general commentary or if you need any assistance, and one of our staff will be on hand to help you with any technical difficulties. So quick final reminder to the panelists, if you can remain on mute until I introduce you between the speakers. And if we can go to our first speaker, I shall introduce you to Jennifer. She's from the Offshore Renewable Joint Industry Programme, a UK-wide collaborative programme of environmental research with the aim of reducing consenting risks for offshore wind and marine energy projects. So over to you, Jennifer.
Thanks, Steve. Can I just do the usual check that you can hear me and you're starting to see my screen?
Yep, all well.
Fantastic. Okay. Let me just see. Okay, great. So thank you for that introduction. I am Jennifer Fox. I'm a senior consultant with Aquaterra, and I'm also the program manager for the Offshore Renewables Joint Industry Programme, or ORJIP, for ocean energy. So I'm going to just take a few minutes to introduce you to ORJIP Ocean Energy and to talk a little bit about another one of our projects which lines up with ORJIP really nicely, called Seawave. Hopefully many of you are quite familiar with ORJIP already, but for those who aren't, I'll provide just a little bit of the background and focus in on some of the key pieces of work that we've done over the years through ORJIP. So essentially, ORGIP is a UK-wide programme, and the aim of the programme is to ensure that environmental consenting risks are addressed by facilitating a strategic, coordinated and prioritised approach to the environmental monitoring and research around wave and tidal energy devices. And there's a number of ways that we as a Secretariat work with a diverse group of stakeholders, as well as a wide international network of interested people, as well as a steering group, to achieve that aim. And I've listed just some of them here, which include knowledge dissemination and sharing through the international network, knowledge collection and collation. The forward look document is something I'll go into a little bit of detail about in just a minute. Also things like development of guidances and tools around consenting and working with regulators and developers and researchers to build those kind of guidances and tools. And a key one is the collaboration with other groups and organizations that are working towards similar aims. So the forward look is a key document that ORGIP first developed with the work of many different stakeholders in the UK back in 2015 and was updated in 2017. And what that document is essentially a list, a prioritized list of the key environmental knowledge gaps that exist within the potential environmental effects of the wave and tidal industry, and a list of the strategic research projects that go alongside those knowledge gaps that would address those key consenting risks. So within that document, it sets out the purposes, required timing, and general scope of what those research projects could look like that are presented in that prioritized way to address the knowledge gaps. And the overall objective of developing a document like that was firstly to inform the focus of ORGIP Ocean Energy, to be able to gather that information and the prioritization effort from our stakeholders and our network. Also to ensure, as is the main aim of a program like ours, that research is focused on those priority consenting risks so that we can learn the most important things and reduce those uncertainties that exist around environmental issues to progress with the streamlining of the consenting process. Also ensuring that projects are coordinated to avoid duplication of effort, and ultimately to aid in the development of research proposals and funding programs. So just last year then, as part of an update to that forward look document, in late last year, we published the Wave and Tidal Stream Critical Evidence Needs document, which is essentially quite a similar document to the forward look, but obviously 3 years hence. The main aim was to update that prioritized list, taking account of the increased evidence base since 2017, and I hope most of you will agree that there has been a lot of learning that has taken place, and really a lot of growth in the evidence base for many of these issues. There was also an effort to align the work that we do with the work that the team at OES Environmental do, obviously with the State of the Science report that came out last summer, which was a huge update to the previous version of that document, and really sets the scene on our awareness and our knowledge, our current state of knowledge on these various different issues. And finally, to present that information in a succinct, focused and user-friendly format that makes clear the links between the evidence needs and their practical application to consenting. So I don't have time to go into these critical evidence needs in detail, but I did just want to give you a bit of a flavor of what's within this document and what the kind of things are that we're talking about when we talk about the critical evidence needs. The first thing is there are a number of cross-cutting themes that are relevant to all of these issues as we discuss them, and I think some of these are likely to come up in our discussion after the presentations today. They're nothing new, but definitely key prioritized themes that come up time and time again, and those are the better use of the existing and new data, sharing, dissemination and accessibility to data and to knowledge, transferability, acceptance and uptake, and risk management. And so just to quickly take you through the top 10 critical evidence needs that have been identified in this document. Obviously in the document itself, we go into these in a lot more detail. I've just taken the titles here, as I say, to give you an introduction to them. The first four here are all around measuring mobile species occupancy, fine-scale distribution, and behavior within these high-energy environments that are likely sites for wave or tidal energy. So having the right kind of methods and instruments, understanding the near field interactions, so up close with the devices themselves, and also the far field interactions to understand if there might be a risk of collisions or a displacement effect or a barrier effect, and also understanding the baseline of those occupancy patterns and distribution of those mobile species. Number 5 is around the acoustic profiles. So definitely there is a strong evidence base around the underwater noise potential impact with wave and tidal, but there is more to learn, I think, in this area. And so having those improvement in the subsea acoustic profiles, both of the wave and tidal stream sites and also the technologies. The 6th one is about the population level risks. When we look to large scale wave and tidal stream development, really getting an understanding of where there could be population level effects to mobile species, and having the right kind of tools to be able to assess that is something that's still seen as an evidence gap. And then the number 7 is around physical processes. Number 8 is around the socioeconomic impacts, which we don't always, group into the environmental side of things, but is a really important one when it comes to consenting. The 9th one here, sorry, I'm going through this, you probably can't read it, so apologies for rushing through everything, but very happy if anyone...
Oh, got me.
Broken up a bit there, Jennifer. You got about a minute left as well. Okay. Sorry, no, we've still lost your sound there. No.
Now.
Oh, got you. Yeah.
Oh, apologies for that.
All right.
When did you lose me? Around socioeconomic?
Talking about box 9. Yeah. Okay.
Which show?
The tools for assessing climate change impacts, I think.
Oh, okay, great. Okay. Yeah, so I think just to reiterate, to really look at why it is that we're developing the renewable energy industry as a whole. Ultimately, we're looking towards these net zero goals, and we really want to be able to assess the climate change impacts when we are looking at consenting wave and tidal developments. And the final one here, number 10, is around tools and guidance for managing risk and uncertainty during the preparation of project environmental monitoring plans. Okay, so I'll move on, as I know I'm short on time, and that was a bit of a rush through, but as I say, please do ask questions. I'll be happy to talk about that a bit more. I just wanted to give you a very quick introduction to the Seawave project. Hopefully some of you will be familiar with this project already, but if you're not, this is a project that is built around the collection of monitoring data around wave energy deployments, and it's being led by EMEC, who are based here in Orkney. And there's kind of 2 sides to the project. So the first side is around collection of new environmental data, as I said, around deployed wave energy deployments, looking at key things like fish aggregation effect, artificial reef effects, fisheries displacement, and disturbance due to physical presence. But there's a second part of that Seawave project, which is where the work that ORGIP does really fits in nicely, and that's these kind of desktop-based critical analysis style pieces of work that we're undertaking as part of Seawave. I've just listed a couple of them here, and you'll likely hear more about them in the coming weeks and months as we really get into the development a bit further. So looking at things like mitigation, monitoring, and management methodologies, having a critical analysis on their efficacy and potential improvement or best practice in the use of those kind of methodologies, and recommended techniques and capturing case studies around impact assessment and also real consenting case studies as well. So I'll leave it there. I know that was a little bit of a run through quite a few things, but as I say, my contact details are on the screen there. If you're interested in ORGIP, please get in touch, and happy to answer any questions afterwards.
Brilliant, awesome, Joachim. Thanks very much, Jennifer. Covered a lot of ground there in a short time. So please carry on asking your questions in the chat box, and we should have some time to be able to ask Jennifer a bit more towards the end. Right, our next speaker is Louis Levay. He's from the Center of Applied Marine Sciences at Bangor University. The CCAMS2 project supports developing economic opportunities in low carbon energy and environment through specialization in commercial application of research and innovation in marine renewable energy, climate change resilience, and resource efficiency in Wales. So over to you, Lewis.
Steve, good afternoon, everybody. Hope you can hear me. Yes, so in this short presentation, what I really have only got time to do is give you a really quick run through the kind of scope of the CCAMS projects. And this dates back over 2 programs, really. We have the first CCAMS project, which ran till 2015, which was not so marine renewable energy focused, but started to do quite a bit of MRE work. And then the last 6 or 7 years or so, under which CCAMS2 has had a very strong marine renewables focus. So this is obviously with ERDF support and has been delivered through the 2 partner universities at Bangor and at Swansea. Jay, can I have the next slide, please? Okay, so I think it's quite interesting, following on from Jennifer's presentation about ORGIP and the ORGIP priorities. I think one way that CCAMS differs from a traditional academic type of project is that we have the overarching funding that we're working within, but within that we set up a whole series of mostly bilateral, sometimes small cluster collaboration projects between 2 partners or groups of partners. And that enables the industry partner to link up with the academic partner and focus on particular either research opportunities or issues that they face in their own development. And so there's a lot of adaptability and evolution of the scope of work done over time. So that the focus in our MRE related work has been in tidal stream and wave and tidal range and supply chain. And this adaptability has enabled the CCAMS teams to work with most of the stakeholders that are interested in developing marine renewable energy in Wales and the organisations and supply chains around them. I suppose also important to think about the fact that this is industry-led. So each one of those collaborations is what is actually trying to do in terms of research is defined by what industry have been looking for out of it. And so that's really helped focus, and then it's co-working as well. So the delivery is about both the academic partner and the industry partner bringing something to that partnership in terms of resource and capacity and people, and then delivering the projects. And finally, a key thing to think about is that because of the nature of the public funding into this type of collaborative research is that the results end up in the public domain. So all the results are coming public eventually and will go to benefit the wider sector. So next slide, please. So this sort of evolution or adaptation through the course of the projects is quite interesting. So what the different this wide range of over 80 projects has undertaken, the kind of research undertaken has changed over time. Early on, companies were more interested in, or most interested in, the resource itself. So there was a lot of work on assessing tidal stream and wave resource at a range of scales, from really site characterization and local effects through to broad scale regional and national assessments of resource, and then out wider to continental shelf scale. And that's been a mix of oceanographic observational work, which has informed development of the hydrodynamic models which have been used for the characterization of the resource at all these different scales. So that was really where things started out. If we move to the next slide. Next slide, thanks. Yeah, so at the same time, and growing more as we went through the program, we have more and more activity in and around environmental interactions, and this is where I can actually map quite closely back onto the priorities that came out of the ORGIP report from last year. So example here in terms of physical processes on a range of scales, and this is largely these examples here are focused on effects on seabed. So it's a little bit blurry on my screen here, and it might be on yours as well, but that's a series of multi-beam images in the boxes going across the middle of the slide, showing time series sampling, which can give you kind of a monitoring time-lapse effect, looking at changes in the seabed, either on a very small scale, looking at scour, or broader scale, looking at bedform changes over time. And then going up to looking at far-field effects through modelling, largely looking at location and scale of arrays, and then how that could affect seabed, both through accretion and scour, on a different range of scales. So but that's also linking modelling to observational work. Next slide, please. And a key element, now these three slides can't cover all the work that's been done under those 80 projects. It's very diverse, but a really core body of work that's developed, and more so in the last 2 or 3 years, has been around ecological interactions, and this really maps onto the critical evidence needs from the ORGIP report in relation to mammals and birds and fish, in terms of their how they use these high energy sites, their patterns of occupancy, their behaviour at those sites, and then all of that feeding into trying to fill some of these evidence needs and knowledge gaps that ultimately will inform the potential risk of collision or displacement. And I should stress here, this is quite different, I suppose, from the type of survey you might need for EIA type work. It's much more focused on developing methodologies to try and gather this evidence, and how do we go about collecting really quite difficult ecological information at difficult sites. Next slide, please. Next slide, please. Okay. So last but not least, of course, is we want to get it's within our remit. I think this also maps into this idea of information being accessible, is get the information out and the data out to benefit the sector as broadly as possible. Now, we can do this through all the traditional means, so that's publications and reports, which will be available, becoming available as projects get concluded, and presentations at conferences. We also have set up the Amadis data management and dissemination system, which you can find on the link here, which is where original data collected during the whole program is being made available. It's QA'd, it has all the metadata attached, and it's in a cloud storage system where you can explore it and go through a data discovery process and download data that you're interested in. And there's also setting up there for real-time streaming of observational data from field stations. So that's all in progress, being set up now as we head towards the end of the projects. And I guess I would close on that, really. So we're in an extension phase at the moment under this ERDF funding. CCAMS is running until, it says 2021 on this slide, actually it's almost exactly a year from now, at the end of January next year in 2022. So we're still open. There are still opportunities to develop collaborations. So this is really a plea to come and take advantage of the resource while it's here. And I guess I would also like to, really, for the discussion after this, to say just to make a point, we have developed some really excellent ways of working between academia and industry in a very responsive way to address industry needs. And really what we need to now look at is how do we build on that and extend into the future beyond the end of next year to support the sector here in Wales. Okay, and I'll stop there.
Brilliant. Thanks very much, Lewis. That was very, very interesting. So our next speaker is Professor Ian Masters. He's from the University of Swansea, and he'll be telling us about the Selkie project and the Marine Energy Engineering Centre of Excellence.
Great, thank you. I'm going to talk today about two aspects of research, and perhaps at a higher level than we have been so far. The first thing I'm going to talk about is the knowledge hierarchy, where you turn data into information and information into knowledge. And second, I'm going to talk about the value of collaboration. And then after I've done that, I'm going to finish by talking about two projects I'm involved in, CELCI and then the Marine Energy Engineering Centre of Excellence, or MEES for short. So the first thing is data. Now, data is important. We collect a lot of data out at sea from prototypes, and in some cases, you might want a university to help you collect data. As an example of that, we've just been working on a project called SurfTech with Sustainable Marine Energy out in Canada, collecting live data from their platform at very high quality and at very high resolution, trying to tie together the platform movement and the performance data. Now, the problem is a lot of what we collect just sits on a hard drive. We all have data sitting on a hard drive, and we might have spent a lot of money collecting it out at sea, and sometimes it's valuable and sometimes it isn't. And I presume it would be really helpful to lots of people if we got that hard drive of data and actually delved into it, and you had a university partner that could help you to understand and really get to the bottom of what that data is. So when you've got your data, that brings you onto your second stage of your knowledge hierarchy, information. For information, I'm going to use this graph. And what you do with information is you take data and you draw some relationships, and you might plot one variable against another on a graph. An example of where we're doing that is we've taken ADCP signals and we've transformed that into a relationship where we understand the turbulence in flowing water, and we're able to separate out both waves and turbulence into separate data streams. And to do that, we've done some quite clever mathematical modeling. Okay, let me just start my slides at this point. Oh, that isn't going to help very much. Hang on.
Don't worry.
I've forced that up and it's not going to let me do what I wanted it to do.
Oh,
okay, so we talked about data and we've talked about information. And the third stage is knowledge. And knowledge is what happens when you take data and information and you have something useful. And knowledge is what information tells you. It's the consequence of it. It's the action you then take. So we all have a need for knowledge and a need for data and a need for information. And there's real value in engaging with the university community. And we've seen some great examples from Lewis there about how those things, all three of those stages, can be useful. The second thing I wanted to talk about was collaboration. And what we're trying to do as an industry is take something pretty high tech. We saw some good examples of high tech stuff this morning. We're going to take some high tech engineering, we're going to put it in a difficult environment and hope that it works smoothly and efficiently and effectively for a long period of time. And that is such a big problem that no one organization can solve that. So we have to collaborate. Nobody's got all the answers, and that collaboration is perhaps the important thing. So I've got two specific examples of collaboration I'd like to talk about. Firstly, I'm involved in a project called CELCI, and within CELCI we're running a network. That's a business-to-business network where we're helping people in this sector to come together, to collaborate, to find those key problems. And one organization's problem over here might be another organization's solution over there. And through the network, we're bringing people together to try and solve some of those things. If you're interested in that and want to join the network, please go to the CELCI stand in the exhibition area and talk to Sophie from Mentamon, who's running that network for us. The second bit of collaboration I'd like to talk about is MEES. And one of the things that we're doing in MEES, and there's the event on Thursday to talk about this in a bit more detail, is this idea of innovation challenges. So through lots of talking and consultation, we now understand what some of the questions are. And within the resources that MEES has put together, we're going to try and solve some of those challenges by using a combination of the Catapult and the Welsh universities to try and break down some of those innovation challenges. Again, working together. Okay, so just a high-level overview of these two projects. So Selkie's funded through the Ireland Wales Interreg programme. We have 2 universities and 4 other organisations. Like I said, we've already formed our business network. There's all of us at Ocean Energy Europe last year. And then as well as that, we're developing a set of tools. The tools are open source in techno-economics, moorings, array models, sensors and operations and maintenance. There's an event on Friday talking about the GIS system for Irish and Welsh waters. We're testing those tools against a wave pilot and a tidal pilot. And come to the stand and chat to us if you want to know more about that. The other project which I'm involved in is the Marine Energy Engineering Centre of Excellence. Like I said, there's a big session on this tomorrow, so please come along to find out more about it. It's an £11 billion project, partly funded by the Welsh European Funding Office at WEFO and partly funded by the Pembroke Dock Marine Project under the City Deal. And what we're going to do here is undertake these industry-focused research, design, development projects and demonstration to show that we can actually help and work together in lots of good ways. So really, just to summarize that overview, we want the best knowledge, and to do that we might need to collect data, interpret data into information, and then understand what information is valuable as knowledge. But when we also need to work together. So if you're interested in either of those projects or any of that collaboration, please come and talk to me later in the conference.
Excellent. Thanks very much, Ian. Very detailed and again covering a lot of ground in a short time. So thanks very much for that. Now our next speaker is Catherine Tate. She's from Aquaterra and she's going to be telling us about the reviewing underwater video data and other things like that. So over to you, please.
Hi, so just to check, you can hear me quite well?
Yeah. All clear.
Perfect. Okay. So hi everyone, I'm Catherine. I work in the environmental team at Aquaterra. I support Jen in the ORGIP Secretariat role. My interests kind of lie in the potential impacts of marine renewable devices on wildlife. So today I'm going to talk about a project we did for Nature Scott and which we published just last September. And this was looking to maximise the value of existing underwater video monitoring data gathered around operational tidal turbines. So with the time I have, I will run through the project background, talk a little bit about the tasks and the key project outputs we're promoting, a little bit about lessons learned, and then finally touching on conclusions. So for a bit of background, commercial scale development of the tidal energy sector is challenged by uncertainty around environmental interactions with operating turbines. This uncertainty has led to limited number of consents being issued for projects around the world, and first movers in the industry can also be pressured with time and cost intensive baseline studies and post-installation monitoring requirements. Around the world to date, a large amount of monitoring data has been gathered around turbines, which has not been fully analysed from an environmental perspective. So without learning what's been successful and addressing gaps in objectives, processes and equipment, there's a risk that monitoring doesn't help address uncertainties and can cost valuable time and resources. So lessons learned from previous monitoring is needed to inform future strategic research, project monitoring requirements, and the consenting and decision-making process. So the aims of this particular project were to first review existing monitoring data to reduce uncertainty around potential effects of operational turbines on marine wildlife, and to secondly collate and share key technical lessons learned to date to reduce risk and cost of future monitoring activities. So we approached this with 5 tasks for overall collating, reviewing and analysing underwater video monitoring data sets and producing 3 key outputs as public resources for users within the tidal sector to help develop future monitoring plans and reduce their risks and costs where possible. So the first of these outputs is a global metadata catalogue, which identifies environmental monitoring datasets gathered from past and ongoing projects. It's for various users to help raise awareness of the extent and types of environmental monitoring collected to date by the sector, and also to help inform future the design of future data collection activities. From our work in reviewing and analysing these data sets, we produced 2 tabular underwater video data analysis protocols. The first is to review the entire monitoring system, and the second is for environmental analysis. And the purpose of these protocols is to help standardise the approach to data collection and analysis in order to provide a framework to allow comparison between data sets. And the intention of these protocols is to help improve stakeholder and regulator confidence in the analysis of the data, as well as to help streamline the consenting process for future development. And last is the main report, which distills lessons learned from our assessments into 36 recommendations on the monitoring system around planning and design, data collection, and review and analysis stages. And this main report is intended to be promoted by regulators and statutory advisors to developers during the consenting process and through consultation. So in terms of the general lessons learned, they're presented in the main report, and I'm just touching on a couple today. Overall, we found that the analysis to date showed underwater video monitoring around operational tidal turbines appears more focused on technical and performance-related objectives rather than working to understand near-field wildlife behaviour around the turbines. A range of technical lessons were learned to improve the quality of data sets for the objective of better understanding near-field wildlife behaviour. And this included recommendations on camera equipment positioning and functionalities, data timestamping and storage, using algorithms to automate processes, as well as 30 more that you can find in the main report, which we'll link in the sidebar. In terms of, or when it came to analysing wildlife near the cameras, we found that 3 data sets were most suitable for this purpose. Wildlife observations were generally low, with about 22% of all the samples we reviewed showing notable events. And I don't know if it shows well on your screens, but in the bottom corner we have an image of fish aggregating around a stationary turbine. And this was the most notable behaviour that we recorded in these assessments. And this was during a very weak current. The turbine was stationary. And last, no collision events were observed in any of the samples reviewed. So in terms of future recommendations, the goal is to continue developing the evidence base for near-field behaviours around operating tidal turbines. And it's recommended to do this by continuing to collect high-quality underwater video monitoring data and developing suitable automated analysis software and processes. During this project and afterwards, Aquaterra worked with developers to help them align their setup and operation of their monitoring systems in line with the recommendations set out in the report. And this has generated video data that is of improved quality and suitability to better understand near-field wildlife behaviours. Another achievement is the dissemination of the project and its resources through the UK-wide ORGIP network, which Jen has discussed today, and internationally through the Ocean Energy Systems Environmental Initiative through the Tate knowledge base. And lastly, Aquaterra is now planning the next phase of the research, which will see a collaboration between industry and academia and continued dissemination of the lessons learned via ORGIP and OES Environmental to ensure that the information gathered achieves maximum value for the industry and for key stakeholders. So that's a very quick run through of my the project that we did for Nature Scott. And again, as has been said, I'm happy to take any questions to discuss later. Thanks very much.
Brilliant. Thanks very much, Catherine. And for those of you who are viewing the chat bar, you'll see that Jay has put down links to some of the additional information from Catherine's presentation there, so you can find out some more. Excellent. So we've got one more presentation before we move on to the questions and answers, and that's from Rob Spice from ITP Energized. Over to you, Rob.
Thank you very much. Can I just check you can hear me okay?
Yeah, all clear.
Grand. Okay, good afternoon, everyone. So my name's Rob Spice. I'm a consultant engineer at ITP Energized. I'm going to talk to you very briefly today about two pieces of work we've undertaken over the last few years, with a bit of a spin on research and collaboration, which has been identified as a real key factor for industry. So I'm going to talk to you a little bit about offshore wind in the southwest, our previous experience on this kind of work and what we're now doing, and a little bit of a conversation about dynamic cable rating, which is a bit closer to home for me. There we go. So I won't linger on this slide. Our experience at ITP Energized is quite broad. My experience at the company over the last 3 years has really been focused on tidal energy, also wave energy devices, but really more recently, the offshore wind sector has been a large portion of my work. So jumping in 2020, so last year, ITP Energized worked with the Offshore Renewable Energy Catapult to investigate areas of least constraint within the Southwest Marine Plan offshore area. And this was quite an early stage piece of work that was building on some previous work that we had undertaken for Simply Blue Energy to try and identify this area of lower constraint. That's not to say it's low constraint or easily consentable. And really the key part of this project for us was just bringing together the data that OREC had and ITP Energized had gathered over a few years to build a bit of a framework and a base case for the capacity that's capable of being developed in this region. And this was quite important. I think it's a good step where collaboration is needed at this early stage, and it's been really beneficial. So we find ourselves in 2020 presently supporting Simply Blue Energy with the electrical design for their current Erebus offshore wind farm, and also leading the environmental impact assessment onshore for that project as well. And that together with some of the work that we're currently doing for OREC, investigating the capacity of the Welsh grid, is really just moving things along from this very early stage capacity assessment. And it's an example of how collaboration at any stage of a kind of life cycle of a project is really key. And we hope to continue working with various organisations in the sector to help deliver offshore wind in the southwest in Wales. So moving on now to a project that's a little bit closer to home for me. So recently ITP Energized, along with Cathy Associates and the University of Southampton, are collaborating on a project with the Carbon Trust to investigate the impact that soil thermal properties have on the cable, on the rating of electrical power cables, offshore wind power cables. And the focus of this work really is about bringing together data points that Cathy Associates and the University of Southampton have been gathering over years of research, and bringing it together through ITP Energized and our experience of cable rating to industry standard in a way that can provide a real practical benefit to the industry. And really this kind of ties back to what Ian was talking about earlier. So in terms of having data points, using that to create information. So and then using that to inform a knowledge base. So what we're hoping to do as part of this project is to use not only the data points that the two organizations have gathered about soil thermal properties, but also we hope to be able to use distributed temperature sensing data taken from actual cables that have been installed for a number of years now to help progress the design of these offshore cables. And the piece of research that's really at the heart of it for ITP Energized, what I'm most excited about myself, is this transition from using fairly crude calculation methods to something that's more applicable to how we should be operating and designing cables in the future. So traditionally, and for a long time now, we've been designing cables based on a steady state cable rating using the International Electrical Commission's IEC 60287. And that's kind of represented by this red line you can see on the top of the lower plot there. And what this assumes is that you take a worst case cable current from an offshore wind farm, and then you calculate the requirements for your cable based on that cable current. And what you end up with is a perfectly well-designed cable, but with a lot of additional capacity that's available and is not being utilized by that cable. It doesn't account for the fact that wind is a variable load, and therefore the current that goes through the cable is also variable. So for a number of years now, cable manufacturers and consultancies have been using a single or multi-step transient model, which is identified by the upper plot you can see on this PowerPoint slide. And what this does is it assumes a period of time in which the current going through the cable goes through some step changes and increases. And this is a crude representation of a worst case wind event that might last a couple of months over the period of the wind farm's life. And this is represented crudely by this yellow line on the lower plot. And we can see here that what we're now doing is making a little bit more use of the capacity that's available within the cable. And this allows us to essentially bring through practical cost reductions for offshore wind farm cables. So this is something that we at ITP Energized have done now for a few developers in Europe and Asia alike. And we've seen practical kind of cost reductions, either through the reduction in cross-sectional area of the cables themselves, or through, in some cases, a reduction in the number of circuits that's needed to connect that offshore wind farm to the grid onshore. And what we're hoping to do as part of this project, and what we're really excited about, is to take that one step further and use this distributed temperature sensing DTS data and couple that with a new model based on the IEC calculations that will allow us to kind of match this time varying nature of the current through offshore wind farms through these export cables, and allow us to rate these cables in a way that reduces the amount of additional capacity and therefore it increases the CapEx savings. So it's a piece of work that's ongoing at the moment. We look forward to sharing some more information about it soon. And I think it's a great example of collaboration between industry, so consultancies, as well as research organizations such as the University of Southampton to kind of action real practical changes to the sector. So that was a quick flyby of those two projects. Thank you for listening, and I'd be happy to field any questions. Cheers.
Excellent. Thanks very much, Rob. Okay, we've got to about 20 minutes for questions and answers. So thanks all of our speakers for staying on schedule. That's great. So I guess us losing Tim gave us a little bit more time for everybody to fit their presentations in. So I'll start. I do have a few pre-prepared questions, but before I get to those, we'll run down through the ones that appeared in the chat box.
I've picked a few out from the chat, Steve. We've had a few comments from James McKean. He has a question specifically for Jennifer. What would you regard as being the next stage following on from the publication of the report?
Yeah, thanks, Jim. I think that's a really important question. So the report in itself is essentially a presentation of where there are gaps and gaps that need to be addressed. And so the next step for us is for that to be used as much as is possible. And the first part of that is me telling people that we've done this report and, you know, putting it out there, disseminating that in the right way so that it's available for people to use. And the second part is that is that use. So our intention and our hope is that this makes it more straightforward for research organizations, universities, and funding bodies to know where to prioritize research. And while ORGIP can't fund the research ourselves, we're there to support the development of proposals and research programs as best we can. And so this report is the first step in that, but really it's all about how it gets used by, you know, the researchers themselves, as well as the funding bodies to put those mechanisms in place to address those gaps.
Thank you, Jennifer. We've got one more question from the chat from Joseph Kidd, and here's a general question regarding the environmental research. We seem to be focused on almost exclusively on monitoring around operating devices to fill evidence gaps, which, as discussed, has limited progress to date. Could we also be looking at other ways of assessing behaviour of mobile species, e.g. SAMS played turbine noises to see marine mammal behaviour when the tidal sites are being used? Does anybody have any thoughts they'd like to hop in with on that one? Lewis?
I'm not actually familiar with the SAMS work that Joe's referring to, but I suppose that a lot of work is elsewhere, and certainly within CCAMS, which I guess reflects what's been done elsewhere as well, is not just about where the devices are in place. It's trying to understand how different species utilize these high energy areas. So it's in terms of just trying to understand, I mean, for marine mammals, how they use high current areas over tidal cycles at different states of the tide, and diving behavior, what depth range are they using, and also behavior of so prey species or pelagic and mesopelagic species with depth over tidal cycles. And that can be over analogs, if you like, for operating tidal devices. It could be over other structures which can give you also a wake effect, for example. So there's a whole range of different work going on, I think, that isn't just around devices. So it's I think it's more than that. I don't know if the others want to comment on that as well.
Yeah, I would just agree with exactly what you said, Lewis. I think there are definitely opportunities for us to progress and address some of the evidence gaps, even when there isn't a huge amount of you know, turbines or wave devices active in the water. Yeah, and I think a really important part of what we've looked at is exactly like you said, the baseline data about the behavioral and the distribution of these animals, but also the tools and the methodologies that we use to collect the data in these high energy environments. That's a really challenging thing, as we've seen time and time again, to have, you know, really good grip on how to use the instruments for data collection, etc. And so we can do that. We have the high energy environments to do that even without, you know, deployments happening there. And so there's definitely a lot of progress that can be made without devices in the water. I would just add to that, there's nothing like having that real project level monitoring, post installation monitoring opportunity. And so yeah, I wouldn't want to say that that's not important, because it absolutely is, but I think you make a good point, Joe.
Mute there, Steve.
Yeah, I was moving to the button, the dread phrase, mute. Yes. So any more comments from the panel on those points that were just addressed by Lewis and Jennifer? Otherwise, we can move on to some of the other questions that we've had sent to us. One of them is, of course, collaborative EU projects have produced a vast amount of significant research and data. What are the UK EU opportunities post-Brexit? And I think Ian, to some extent, addressed this, but anybody got any further comments on that?
So just to clarify, as part of the Brexit deal, probably the first person, not the first person today to mention that word, the UK has agreed to contribute to the Horizon Europe programme. So there's an opportunity for UK-based companies and research centres to fully collaborate both in the current Horizon 2020 programme, but also the future Horizon Europe programme. So that's really exciting. You know, it's going to be tough competition-wise, both with other excellent universities and partners. But I think it's worth that opportunity to stay within that wider framework, and it just brings so much more expertise and understanding to the table than not. You know, the UK research community is very active and very good, but if we bring our partners in from Europe, that strengthens things a lot as well.
Okay, no, that's a very good point. Thanks to you. Anybody else got anything to comment on the post-Brexit aspect? Otherwise, I'll move on. Another of the questions we got asked was, how do you balance protecting your intellectual property with making data available to progress the industry and save everybody reinventing the wheel? So it's always a tricky one to reconcile. Anyone have any thoughts on that?
I can maybe just kick us off with a short comment. So through ORGIP, we asked EMEC, the European Marine Energy Centre, to do a short report on the sharing of environmental monitoring data last year. So it's a really nice, concise report, and happy to share the links to that if people are interested to read more on it. And the sharing of environmental data is definitely a big issue, and some of the other speakers touched on it today. I think it's something that does come up. The comment that I would make on it is that, and from what we've seen in EMEC's experience, is that for the most part, industry folks within the wave and tidal industry are very aware of the early stage that we're at, and the need to collaborate and work together and not be too protective of that kind of information at this stage. And I think we need to embrace that and work on making that as easy as possible for developers and researchers to keep that kind of collaborative approach going as the industry develops and grows.
Yeah, no, I would kind of like to build on that, Jen, because that was the document that I was thinking about as well, and just having gone through it and picking out particular points which could be up for further discussion is one potential solution, learning from the offshore wind or industry, is can we anonymize data outputs so it protects the data generator, the developers, but it's available for use by other organizations to help further their understanding. Or the other potential that I picked out from that report is, can we disseminate raw data publicly but hold analyzed data confidentially? That could be a potential way forward, but the only thing we would need to be careful for that is making sure that, you know, the people that are analyzing that data externally, they're not kind of having opposing research objectives that may cause misinterpretation or a misleading publication from that available data. I don't know if anyone's got any more thoughts on that.
Yeah, so I think a few points there. I suppose from the academic side, of course, we want information out there, we want to publish, we want information to be in the public domain. And my first point would be the experience of working with many industry partners through these EU-funded collaborative projects, where the information is going to end in the public domain. I think I've just been really impressed by the commitment from the companies to make quite significant investments into their own project, knowing full well that the results will go out eventually into the wider domain. So I think that's a positive. So I think there's obviously will to do this on a central level. I think that's. I think that making data public. That's quite an interesting question. I don't know if there's anyone here in the audience from the Crown Estate. So the Crown Estate licensing is now requiring data to be shared, and I don't know how that's impacting what private sector actors are doing in terms of committing to make their data public, but certainly for any licensing we obtain now for research, the data will go automatically, have to go into public domain through the Crown Estate or on behalf of that.
And it's the same for much of the European funding, isn't it? Everything has to be, or nearly everything has to be made public.
Okay. Now, one question that's come.
Can I just add a comment on the engineering research side on this idea of sharing data? One of the things we've sort of worked on is keeping our partners' data confidential, but the methods and the tools that we're developing and testing against that data, those become more publicly available. So we have a couple of tools for turbine performance, and we're confident that those tools work and they give you a good result, because in the background we've done a piece of work with a company in private that nobody's seen to prove that tool is accurate against their measured data. But what we can then say is, well, this tool we've developed, if we know it works, we can't give you the data set that we tested it on, but we can give you the tool. And that's quite a nice way around that problem. And in some cases, there's obviously university generated public data, again, which you can benchmark against. So it's a question of trust, and it's, people share their data with us under particular conditions, and we respect that 100%. But then something comes out of it which is more valuable to the whole community.
Okay. Robert, do you want to add something there? Or?
I just think you've made a really good point there, Ian. From our experience, I think that's certainly from data points for engineering design work. So I mentioned in the presentation cable design work. There are aspects of cable design where the only way to move forward is to have data given to us by developers or OFTOs, offshore transmission operators. And the only way that we can really agree to develop models that we have accuracy and confidence in is to validate that against real data, and then promise to not share that data, but use the models and have confidence in them. And I think that's a key step forward from a technical perspective. So yeah, really good point.
Okay, excellent. Thanks, Robert. Lewis?
Well, I guess it's not just about sharing data, but I think it's about making sure data is preserved and accessible, because I think so much data has been collected over the years and then is lost in the midst of time and it can't be accessed, and people have to reinvent the wheel or spend the money all over again and do repeat what shouldn't have been lost, and that's really so it's encouraging people to take advantage of whatever other facilities there are. I mean, we've set up the Amadis platform for making sure data has longevity, but there are all the other BODC and others that, and just encourage people to use them, because if you go to people starting to work in Welsh waters and need to understand even basic stuff like bathymetry, there's so much data that's been collected that just isn't available and could have been, and companies are having to start all over again. So I suppose that's just a plea for people to take advantage of the platforms that are there.
Okay, thank you. And one of the questions that's come in is one about how we work, we get out of our silos and work into some of these broader communities. And somebody's asked, is there more that should be done to collaborate with the software engineers who use artificial intelligence or machine learning to process large sums of data more quickly and help bridge some of the evidence gaps, for example, in species behavior? Any thoughts there from anyone? Is it a bit outside the comfort zone?
I was going to say, from the perspective of my specific project, where we're hoping to move on to phase 2, that is developing these automated image analysis techniques to go back to the data that was manually reviewed. I think it's important that we kind of bridge that gap with the software developers and work together to formulate technology that's suitable for these environments. We're going to hopefully be working with Pacific Northwest National Labs, who have developed their IC software, which is an algorithm that is able to detect fish and try and fine-tune it for what is essentially difficult video footage to assess using computer algorithms. I'm not a software engineer, so that's as far as I can kind of take it on that. But I think it's important that we do kind of keep that collaboration up with these in this area.
Yeah, I think I'd second that. I think there's the challenges of collecting large data sets in difficult locations. So there's all the storage and transmission issues around that, which is kind of an engineering and data problem. But then there's the interpretation and extracting information out of the data. So, you know, the opportunities for streamlining data at source, which is a software question, and then processing it and extracting that, whether it's fish presence data or acoustic data from marine mammals, whatever it might be. I think there's a lot of scope for crossover with AI and software developers. I think that's something we should really be encouraging, to just try and make this data collection more streamlined and more practical, and with just in terms of data cards and batteries and staff time looking through video, all these things that, you know, are logistic blockages in the whole process. So.
Okay, thanks.
Can I, related but different note, we've had some success with using open source software that's been developed for other applications. So at the moment we're doing some drone work, trying to map surface currents using video footage from drones. And the tools we're using to do the mapping are open source and developed in a completely different context. So it's quite nice to actually, you know, go and delve into some of these community software packages, and then you can reap the benefit from that, from using those open source systems. So, for example, within Selkie, we're developing an open source turbine array modeling tool, which itself is built on an open source flow package. So the software we started with, we pulled an open source tool in, we've modified it for our applications, and we're going to publish it back out again. So just by taking open source and then contributing back to the open source community. And that I think is one of the good ways to go with this concept.
Thanks. And Jennifer, you wanted to make a point?
Yeah, I was just going to add to what Catherine was saying, and I think it's a really good question, because it's totally vital that we as ecologists or biologists work with other types of experts to be more than the sum of our parts, hopefully. You know, I think some of the learning that we had from the video data project that Catherine was talking about was about the importance of being involved, particularly with engineers, but also equally software developers, right from the early stages of design of a device and its associated post-installation monitoring program. So really practical things like, where can you put a camera that makes sense from an environmental point of view and also an engineering and design point of view. You know, those are some really practical lessons learned that I think emphasize the importance of that. And it goes to what Ian was saying as well about the importance of collaboration across our different areas of expertise.
Brilliant. Excellent. Thanks very much for that. Now we're into the last 5 minutes before we need to start winding up, so people can go across for the wind-up session. David Mills has just asked, he's just making the point about, there'd been a potential for the application of machine learning and AI techniques to develop the speech analysis for processing acoustic signals from cetacean monitoring systems. That's quite an interesting point. I do have one question here. Somebody's asked me, general question on collaboration in the post-COVID world. Are there any lessons learned that can be applied to future collaboration? Tricky one. I don't know if anyone has any. Yeah, Lewis.
Always have a plan B. That's my only lesson. Or C even, and perhaps D. Yes.
Excellent. And no one else. Catherine, I see William Lloyd's asked, how do you see the work from Aquaterra that's been done in the Far East now being developed?
I must admit, I'm not sure if that's our video review project was focused in Scotland with the data sets we used. I'm not too sure, or perhaps I wasn't involved in the Far East works, but I can always find that out and come back to you with a response. But thank you for asking.
Okie dokie. Ian, you wanted to make a comment? And Lewis. Yeah, Ian first.
I just think that COVID has taught us that we don't always need to be physically in the same place. It's hard doing everything online, but it's possible. Obviously, if you need to go and find a patch of water and take measurements in it, that's clearly a different thing. But I think we can do much more collaboration than we think we can, and the distance isn't always the barrier.
Yeah, well said.
I'm just wondering if that's what the questioner meant, because the other thing, of course, is as we hopefully, touch wood, emerge from this whole crisis, it's the green recovery. This is the opportunity, perhaps, for injection of some both resource and energy into the green renewable sector. Certainly within Wales, I think there's a clear opportunity now, and it ties in with earlier questions of what do we do post-Brexit and funding opportunities. There's definitely the motivation there at the moment for this green recovery plan, and I think it's that side of things. I think we should look at as maybe one silver lining that perhaps can come out of all this. So,
Yeah, it's true. It's not all bad, is there? There have been one or two positives, not many, but one or two positives. Right, well, I reckon we're coming up to the last couple of minutes, so we better start to wind up now. So I'd like to thank all of the presenters for your time and effort, in particular having brought so much experience from across the whole of the UK. And I'd like to refer you all now to go across to the main stage area for the closing remarks from Marine Energy Wales Chair Martin Murphy. He'll be kicking off in about 3 or 4 minutes, so you've got time to quickly pour yourself a fresh cup of coffee if that's what you'd like to do. And of course, we very much hope that many of you will be able to join us at the networking event later this evening. Hopefully those of you pre-booked have had your nice brown boxes with a couple of cans and a marked glass with Marine Energy Wales logo on it arrived. So we shall all indulge in being able to share a beer together at the end of the day. I'm making an exception to dry January for today, as it happens to be our networking reception. So has anybody got any final things they'd like to ask one another? Anything for anyone who hasn't had a chance to speak? Otherwise, I'll say thank you very much. Thank you to all of our audience who've joined us this afternoon. I believe that some of the recordings have been made, so there'll be a way of sharing some of these presentations later on. So thanks very much, everybody, and see you over in the main stage very, very shortly.